Good morning na in advance. Today, we're going to discuss fundamental counting principle and factorials. Ryan plans to have a pasta or a pizza for lunch. If there are 3 different pizzas available and 2 different pastas available, how many meal choices does Ryan have? Pause the video and think of your answer. That's correct. Ryan has 5 choices for his lunch. So he can have a pepperoni pizza, a 4-cheese pizza, a Hawaiian pizza, a carbonara, or spaghetti for lunch. Now, let's take a look at our second problem. Ryan plans to have a pasta and a pizza for lunch. If there are 3 different pizzas available and 2 different pastas available, how many meal choices does Ryan have? Let's have an example of Ryan's meal choice. So one example is it can be a pepperoni pizza plus carbonara. Or another example can be a pepperoni pizza, still a pepperoni pizza, but this time his pasta is a spaghetti. Now, try to list down all the meal choices that Ryan has. Were you able to list down all the meal choices? How many choices do you have? That's correct. There's a total of 6 meal choices. We can make use of this tree diagram for the meal choices. But imagine if we have so many choices, like for example, we have 10 choices for the pizza and maybe, for example, we have another 10 choices for the pasta. Imagine how tedious it will be if we are going to write down all the possible choices. So is there a shortcut for us to be able to come up with the possible choices without having to draw the tree diagram? That's where the fundamental principle of counting will come in. Fundamental counting principle states that if one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. Let's go back to the problem earlier. So in the problem earlier, the first event is choosing a pasta and the second event is choosing a pizza. So the number of ways that we can choose a pasta is 2 and the number of ways that we can choose a pizza is 3. So we just have to multiply the 2 and the answer is equal to 6 meal choices. I'm going to show now some more examples of fundamental counting principle. Pause the video so that you can read the problem, write down your answer, and then play the video again to check if your answer is correct. Good luck! Since there are 2 ways to go from town P to Q and 3 ways to go from town Q to R, then there are 6 ways to do the trip. There are 3 ways to choose the bread and 4 ways to choose the meat, so there are 12 choices for the sandwiches. For the first toss, there are 2 possible outcomes. It can be heads or tails. For the next toss, there are still 2 possible outcomes, still heads or tails. And same for the last toss, still 2 possible outcomes, heads or tails. So in total, there are 8 possible outcomes. Since a die has 6 faces, there are 6 possible outcomes, and then for the coin, there are 2 possible outcomes, heads and tails, so there's a total of 12 possible outcomes for this scenario. There are 26 ways to choose the first letter because we have 26 letters in our alphabet. So that is the same for the second and third letters. And then for the digits, since we have a total of 10 digits from 0 to 9, so we have 10 choices for each digit. We multiply everything and we get 175,760,000 license plates available. But what if The letters and the digits cannot be repeated. Pause the video and write down your answer. For the first letter, we have 26 choices, but for the second letter, we now have 25 choices since the letter cannot be repeated. So the first letter that we chose cannot be included in our choices anymore. That's why we only have 25 choices. And then for the third letter, since we were able to use 2 letters already, so we'll have a total of 24 choices. That is the same for the digits. So at first, we have 10 choices for the digits, but since we used 1 already, for the next digit, we only have 9 choices left. Multiplying everything, we'll get 78,624,000 available license plates. Now, for this example, what if you have to write all the letters of the alphabet? It's going to be very tedious if you're going to write 26 times 25 times 24 times 23 and so on and so forth, and you have to multiply everything. So is there a way for us to write our answer without having to go through that? Yes, that's correct. So we can write our answers as 26 factorial. A factorial is a function that multiplies a number by every number below it down to 1. So for example, 26 factorial means you're going to multiply 26 by 25, by 24, by 23, and so on and so forth down to 1. It is also important to note that n is an integer. Try to answer this next example. Using the definition of factorial, try to evaluate the following expression without using a calculator. Pause the video, write your solution, and check your answer afterwards. We can rewrite the denominator as 5 times 4 factorial. If you're wondering why we didn't write it as 5 times 4 times 3 times 2 times 1, it's because we can see that we can already cancel out the 4 factorial. So cancel out 4 factorial and we're left with 6 over 5. Now try to simplify the following expressions using your knowledge on factorials. Pause the video, write down your solution, and then check your answers afterwards. For number 1, you're going to rewrite the denominator as n times n minus 1 factorial. We're going to cancel out n, leaving us with 1 over n minus 1 factorial. For number 2, you might be wondering, why did we rewrite the numerator instead of the denominator? So imagine if we're going to rewrite the denominator, it's just going to be n minus 2 times n minus 3 times n minus 4 and so on and so forth. But it's clear that we're not going to reach n factorial. So we cannot cancel out anything. Since our goal is to simplify, we know that we have to cancel out common factors. So let's try rewriting the numerator. So we have n times n minus 1 times n minus 2 factorial. We stop at n minus 2 factorial since we can already cancel it out with our denominator, leaving us with n times n minus 1. For the last one, we're going to rewrite the denominator until we reach n minus 2 factorial so that we can cancel it out with the n minus 2 factorial in the numerator, leaving us with 1 over n plus 1 times n minus 1. No need to expand the denominator. Before answering your seat work uploaded in Schoology, you can watch this video again or read the PDF version of our lesson. Remember to take note of your questions as well and the things that you need to clarify so that you can ask them next meeting. Good luck!